Hello and welcome to helpyourmath.com. In this video, we're going to talk about complex solutions of quadratic equations. Now, when we look at these quadratic equations, they're not going to be factorable, so we can either complete the square or we can use the quadratic formula. My default is to go into use the quadratic formula, so that's what I'm going to do in this video. Okay, so we want to solve x squared minus 2x plus 5 is equal to 0. The quadratic formula says x equals inverse of b plus or minus the square root of b squared minus 4ac, all divided by 2a. Well, here a is 1, b is equal to negative 2, and c is equal to 5. We're going to plug those in and see what happens. The inverse of negative 2 is 2, plus or minus the square root of negative 2 squared minus 4 times 1 times 5, all divided by 2 times 1. Under the radical, what we're dealing with there is we have negative 2 quantity squared. That's going to be positive 4. Anytime you square something, it ends up being non-negative. So squaring a negative guarantees that the result will be positive. Be really careful about that. Sometimes in our calculators, we type in negative 2 squared, and then it tells us negative 4, and then we write negative 4, and that's not right. If you're going to use your calculator for this, put the negative 2 inside parentheses. Okay, anyway, where was I? And then 4 times 1 times 5 is 20, all divided by 2. Under that radical, we have, it looks like negative 16. Ooh, look at that. So first of all, when we take the square root of a negative, an I will pop out of the radical. But also we have the square root of 16, which is 4. So we end up with 4i. Simplifying this becomes 4i. So we have 2 plus or minus 4i over 2. And all three terms are divisible by 2. That's going to leave me with 1 plus or minus 2i. So I can say my two solutions are 1 minus 2i and 1 plus 2i. And that's what we would do for this example. In our final example here, we have 2x squared plus 9 equals negative 3x. There's a problem here, and that is we need to have it set equal to 0. So I'm going to add 3x to both sides. And I'm going to put it in the middle because that way the exponents go in decreasing order. So this would be 2x squared plus 3x plus 9 is equal to 0. And then from here I can use the quadratic formula. I have a is 2, b is 3, and c is 9. And just in case you forgot the quadratic formula, you need to know this. So if you don't know this off the top of your head, remember it, remember it, remember it. There are thousands of other YouTubers who have fun songs and dances and whatever to help you remember it. Look those up, but know your quadratic formula. Okay, now let's plug in. We get x equals the inverse of b, which is negative 3, plus or minus the square root of 3 squared minus 4 times a times c, all divided by 2 times a. Let's clean up what we can clean up. So that's negative 3 plus or minus the square root of 9 minus 4 times 2 is 8 times 9 is 72, all divided by 4. So then we'll have negative 3 plus or minus the square root of negative 63 divided by 4. That taking the square root or dealing with that negative under the radical, that means an I would pop out. So I'm going to pop an I out. Then we would have I times radical 63. 63, I'm going to just come over here. 63 has a perfect square factor of 9. It would be 9 times 7. So I can take the square root of 9, so a 3 will come right in front of that I, times the square root of 7, all divided by 4. All three terms do not have any common factors besides 1. So I would leave it like this, although I might separate my two solutions. Or if you want to, you can separate the two terms in the numerator. You can kind of distribute the 4, whatever your heart desires. I usually just separate my solutions. I don't necessarily separate the two terms in the numerator. So I'm going to write this as negative 3 minus 3i radical 7 over 4. There's one solution. The other solution is negative 3 plus 3i square root of 7 over 4. And there you have it. This has been examples of looking at complex solutions of quadratic equations. Thank you for stopping by.